All right, we're back. We're still on page 81. We're still solving trig equations, and we're still using u-substitutions, basically, except on the last one, I didn't really do it. I'm not going to do it on this one either, because I think it's a step that we don't actually need. It's not complicated enough. Maybe it is. So I look at it, I see its sign. You don't really need to label these quadrants every time if you know what's happening. Sign, it's negative, so it's here and here. I know my reference angle is definitely going to be the inverse sine of 0.345. All right, so we get this. And now we're going to say that either 13x over 3 is equal to, so this time there was nothing to like rearrange, which is why you can kind of cram it into less space. It's either going to be pi plus the reference angle, sine inverse of 0.345 plus 2 pi n, or I'm going to have, I don't know, I'm not going to be able to get them next to each other, so I'm just going to do 13 pi, 13x over, I'm just going to put them below each other. So this one, I could do 2 pi minus, or I can just do the negative because it's quadrant 4, so I'm going to do the negative. Negative of the reference angle still puts me in quadrant 4, 0.345, but I still have to add 2 pi n. So let me solve these. So I'm going to multiply by 3, divide by 13. There's almost nothing you can really do here. So this will give me x is 3 pi over 13 plus 3 sine inverse of 0.345 over 13 plus 6 pi n over 13, where n is an element of the integers. And what I'm going to do is I'm going to highlight that because it's going to get lost in the work. So that's a danger. When your work looks worse, it's easier to lose things. And like, God, the amount of time I've, in my opinion, wasted in my life explaining to students why they lost some points because they were messy, I would have a lot of extra time on my hands. So let's not be like that. So at the very least, I'm doing the favor of highlighting when we have a final answer. So here we go. Okay, so let's check it and we'll see. I mean, I usually feel pretty confident about these because unless I do something like kind of dumb, they should work out. So I'm gonna do, what am I gonna do? I'm just gonna do the thing where I like try to check my answer over 3, do such that, and we'll see if we get, so x equals 3 pi over 13 plus 3 arc sine 0.345 over 13 plus, so if you just add one period, kind of like checks all the boxes, negative 0.345, exactly what we wanted. And then the other answer is, I'm going to delete this, and put a negative, and we get it. So we got it. All right, let's go back here and see how it goes. Okay, so this one might be a little different. Let's find out. So there's several ways that you can deal with this. What I'm going to do, there was like a weird noise outside, which is what I'm, there's like something like built a nest right outside of my window, and I have yet to see what it is that did that. It might be a bunch of blue jays because they're floating around right now. It could be squirrels. I don't know. You would think I would know the difference between a squirrel nest and a blue jay nest, but like, not such a nature guy. All right, there's 2 ways you can do, well, there's probably way more than 2 ways you can do this. The safest way, and I know that no one's going to choose to do it, is to factor this. So I'm going to factor this into 2 sine of 2x, because there's a difference of squares, like this, right? So we're getting a lot of solutions here. So here, this gives me sine of 2x equals 1/2. And here I get sine of 2x equals negative 1/2. So there might be more answers than you're expecting. So when you have a difference of squares, the safest thing to do, the absolute safest thing to do is to factor and set each factor equal to 0, use the zero product property or whatever it's called. The less safe thing to do is add 1, divide by 4, take the square root, because people often forget it's plus or minus when you take square root. So I've avoided that by doing this, but you know, you choose what you want to do. So can I combine the work on this? I could. I know that this is like either sine of something is 1/2, so it's pi over 6 or 5 pi over 6, or sine of something is negative 1/2, so it's 7 pi over 6 or 11 pi over 6. So I could just like do them all in one shot, which I'm really tempted to do, but I'm gonna like pretend to not do that. So I'm gonna say 2x is pi over 6 plus 2 pi n. 2x is 5 pi over 6. So these come from here. And then over here, I would get 2x is 7 pi over 6 plus 2 pi n. And then here, 2x is 11 pi over 6 plus 2 pi n. It's like all the pi over 6s are showing up. So now, all I have to do is divide by 2, and then we're pretty good. So I'm actually I'm gonna combine all of these into one final-ish answer. Well, I really can't do that, so all right, here we go. So x is pi over 12 plus pi n. X is 5 pi over 12 plus pi n. X is 7 pi. So we're getting all the pi over 12s. 7 pi over, well, not all of them. All the pi over 12s that have a pi over 12 so yeah, all the pi over 12s. What am I talking? Plus pi n. I'm just thinking about what has an s out there. You let your mind wander a little bit, and you're just kind of like doomed. Which I've become more acutely aware of that during this like self-quarantine, where I'm doing like a lot of the notes on my own than I ever was before. I don't know what, we go back into the classroom, like I might be shutting down side conversations left and right, because like you're just costing yourself your education. You know, I'm like, what's the point if you're just gonna throw it away? All right, so I got a ton of answers. I got 4 answers this time. I think the calculator is just gonna solve this, so I'm gonna ask it to. So instead of trying to check my answer, I'm gonna do solve for sine of 2x squared minus 1 equals 0 for x. And then I gotta expand everything. Expand this. Okay, expand. I mean, you can look at them and see it, I think. I mean, that's like the easier way to do this. Expand that, that's your 5. Let's take a look. Here's your 7 pi over 12. And then this one, this one's the problem. The one that uses the negative, which I think is this one. It's not like a problem, but if we expand it, it doesn't give us what we got. It gives us coterminal to that. If I add pi, I get 11 pi over 12. So then you can see that it was right. So we definitely got it right. So my advice is, if you see a difference of squares, try factoring instead of counting on yourself to remember to take plus or minus the square root. It's my advice. You don't have to take it. So let's see. Here we go. I'm going to solve it. I'm going to make this cosine of 3x. So I'm still thinking in terms of like cosine of u, like make it an easier problem. But I don't want to have to do the u substitution all the time. Cosine and its positive is here and here. Reference angle. Do I need a reference angle? No, it's radical 3 over 2. It's just pi over 6, right? So either 3x is pi over 6 plus 2 pi n, or 3x, so in quadrant 4 is going to be 7 pi, what? 11 pi over 6 plus 2 pi n. And then we divide by 3, so x is pi over 18 plus 2 pi over 3n, or x. We're just doing this. These notes, I feel like maybe more than almost any others, just like so many practice problems. But people are not necessarily are not necessarily innately good at solving these. But in my experience, everybody can get really good at it, and that's all that matters. Nobody cares if you walk in the room good at something. It's like you're already good at it. Why are you taking the class? You know, don't waste everybody's time. But you can get good at this, and it just takes hard work. And I think that's the best type of thing, where you control the result, because it's all about like how much are you going to put in. I think this will solve correctly. So cosine of 3x. When I say that, I'm not basing it on anything really. I'm just saying like, yeah, I mean, it's a famous angle, so why would it not do? Here we go. And again, with the negatives, so pi over 18, you can just see. The other one, I'm going to expand and then add 2 pi over 3 to see if it matches ours. 2 pi over 3, which is the period, gives us 11 pi over 18, which is what we got. So we nailed it. Let's go back. And we're here. Maybe. Oh, yeah. Okay, we're back. So there you go. That's a full page. A lot of problems. Super good practice though. So make sure you can do them. Search the internet for more problems if you want more problems to do. I definitely recommend that. It's a good thing to do. And I will see you in the next video.